Please, if you can hear me, can you type yes in the comment section? If you can hear me, type yes in the comment section. If you can hear me clearly, can you type yes in the comment section? Okay. So clearly, I hope my board is clean enough. Whatever you see on the board. Okay, that's great. So let me welcome all of you. And as you are joining, let's know where you are joining us from, especially those of you that are already enjoying Christmas. Let's know where you are joining us from. Let's know where you are joining us from. So you can just type where you are joining us from in the comment section. So for those that are joining us, try to call others, as I have something to monitor whatever activity I'm doing. And of course, you know that we are in the technology age. We all agree to meet virtually because I know this time around we are all still enjoying the break. So let's know those that are joining us. So you can go back to the group and tell others that we are live now, so that we can see the others that are joining us. So I'm going to drop a link on this place. Just fill the link with your, just register your presence via the link. So that's how we are going to go about it. So I'm sure we can hear me clearly. So I'll be asking you the question at interval, just to know you can hear me, so that I will know I'm not talking to myself alone. If you can hear me, you can just type it in the comment section. Let me know if you can hear me clearly. Okay. Yes, I can see those that are joining us from Lagos. We can see you all. Lagos people, you are welcome. Oh. Yes, Agege Lagos, you are welcome. Yes, those that are joining us from Lagos, let's know you. Okay, we can see those that are joining from Lagos. We even have some that are in Ijari here in Ijebu-Ode. You welcome. You are welcome. So let's see how we go about it. So far so good. Someone is saying he's joining from Kalu. Me, I don't know anywhere they call Kalu. I don't know anywhere they call Kalu. You just let me know where you are joining us from via the comment section. Just tell me where you are joining us from. Okay. Let me show my face so that you know it's you guys that are on break. As for me, I'm still in the office here because we are looking for a way to make sure you all prepare. As you can see that we are set for you. So let's know where you are joining us from. Let's know where you are joining us from. So I'll be treating some I will start from where we start the class. Then from there we'll quickly look at some little questions that has to do with some of those things that we have done in the class. And that's why I said if you have friends that are supposed to be here and they are not here, it's better you call them now. Call them now. Call them now. Call them now. I'm not going to say more than that. Call them now. Call them now. Of course, you know I don't talk too much. So if you can hear me clearly, can you type yes in the chat so that if you can hear me clearly, type yes in the chat. Okay, that's great. So I'm going to quickly start from let me try to relax here so that we can see each other. All right, so so I'm going to ask some of these questions from us that are pertaining to this statistic class, and I want us to quickly look into them before we move into the calculation aspect of the course. So before we move into the calculation aspect of the course, the first thing we'll look at is, if the paraventure, if you had, can you describe the word statistic? So I want someone to help me to put those things in the chat. The first question I ask you is, you are going to explain the following terms. First one is statistic. Can you type it so that I can have that to follow myself? Statistic. What exactly is statistic? Can I have someone to volunteer to type it? If you can hear me, can you type what I just said now in the chat? Statistics. Can you explain the word statistic? Great. Thank you, Ogunlade. Thank you, Ogunlade. So I will also ask you again, what do we mean by descriptive statistic? Of course, you know I said there are two types of statistic. We have what we call descriptive statistic, then we have what is called inferential statistic. So we'll look at what is the meaning of descriptive statistic, what is the meaning of inferential statistic. So making three, we'll look at the meanings of statistic, the meaning of two types of statistic, that is the descriptive statistics and then the inferential statistic. So can we type it? Descriptive statistic and inferential statistic. So we want to look at the difference between the two of them. Let's type that one in the chat. So making three that I'm asking you now. Can we type it in the chat? Can we type it in the chat? Yes, thank you, Ogunlade. Yes. I didn't ask you to define it for me. I'm only asking you. I will definitely give you a simple illustration. So we are more or less doing review of what we have done pertaining to statistics. So the next one is what do we call parameter test? What is parameter test? So what is parameter test? Parameter test. Someone should help us to type that one too there. Parameter test. If you are using ChatGPT is not allowed here. You know, it's not possible for you to see ChatGPT. Yes, thank you. Parameter test. Then we also look at non-parameter test. Non-parameter test. We look at parameter and non-parameter test. A minute. So okay, so making how many? Can we list the numbers now? Can we list the numbers? Okay, parameters and non-parameter tests. Then we take it away from there. We move to what do we call normal distribution and normal curve? What is normal distribution? What is normal curve? Normal distribution, normal curve. Normal distribution, normal curve. I didn't ask of any number. If you are putting, when it is time, I will definitely, you know me that I will definitely do that. Because I can't, the time that I'm supposed to use to be relaxing, I just decide to use the time. Yes, thank you. So I'm going to define those things. Yes, I'm going to define them one after the other. I'm going to define them one after the other. I will define them after the other. Then once I define that, I will go as well and define some of these. I will go ahead and define some of these terminologies that we use in statistics. So let's start with statistics itself. Let's start with statistics itself. So what do we mean by statistic? A statistic is defined as a science comprising rules and procedure for collecting, organizing, summarizing, describing, analyzing, presenting, and interpreting numerical data, which are used in making decisions. I'll take that again. And of course, like I said, I will still leave this video, will be available here. You are free to come back to the video, but it is compulsory for you to be here so that those that are not joining, you will not see them as a fool. So I have talked about that. So I will repeat that again. Statistics is defined as science comprising rules and procedure for collecting, organizing, summarizing, describing, analyzing, presenting, and interpreting numerical data, which are used in making decisions. Valid estimate, prediction, and generalization. Examples of a statistic report could be talking about how many followers of each religion. As we all know what happened in the year 2023, we had our general election, and there is involvement of collating of result from each collation center. That is a simple illustration of what statistics is all about. And of course, during the process, you will see that it is not possible for someone to collate all the results for the country. So you just have to do it bit by bit. So there are collation center where they collate results. Of course, we have to make, this time around, I think we have 3 major political parties in Nigeria: the People Democratic Party, the APC, and Labour Party. So of course, whatever vote they gather here in Ogun State will be added to those one gathered in Lagos, added to those one gathered in throughout the 36 states that we have in Federal Republic of Nigeria, including the Federal Capital Territory. So by the time they collate everything together now, they will do summation of everything. So that is what statistics is all about. Is a science that comprising rules and procedure for collecting, organizing, summarizing, describing, analyzing. We have some analysts that after collating all the results, they can come around and do the analysis of all the results for you. Everything they are still doing is still work of statistics. And whosoever that is doing that, we call them statistician. So I think with that, I've just give a simple illustration of what statistics is all about. If you get the definition, can you type yes? If you get the definition, can you type yes? Can we type yes if you get the definition? Okay, thank you. All right, so let me move on to the next one. Who can remind me the next thing after statistic? What's the next thing after statistic? What is the next after statistic? With what I've listed, what is the next after statistic? What is next to statistic? It's okay. I know you got it. So what is next? Yes, types of statistics. Thank you, Ogunlade. So, did I got the name right? Yes, Ogunlade Ayobami. So we said there are 2 types of statistics. And we said we have what is called descriptive statistic and inferential statistic. Descriptive statistic. From the word descriptive, when we said descriptive, it simply means you are describing something. It's a matter of just describing something. So a descriptive statistic is an event or outcome of events that are described without drawing conclusion. A descriptive statistic is what? Is an event or outcome of an event that are described without drawing conclusion. It concerns only with collection, organization, summarizing, analyzing, and presentation of an array of numerical, quantitative, and qualitative data. So the only thing, because descriptive statistic is one of the types of statistic. And if you could remember, we said the definition of statistic is science comprising rules and procedure for collecting and analyzing. So therefore, descriptive statistic now is just when you are talking about the event or outcomes of an event that you describe without drawing conclusion. You describe it without drawing conclusion. Without drawing conclusion. So a descriptive statistic is the event or outcome of events that are described without drawing conclusion. It's concerned only with collection. It only concerned with collection, organization, summarizing, analyzing, and presentation of an array of numerical, qualitative, and quantitative data. I will give an example. And examples of descriptive statistics include those things we do. Central tendency, that was our first topic, where we talk about mean, mode, median, standard deviations, and the like. All those one are descriptive statistical tools. Those are those things we use to perform a descriptive statistics. So we said, and examples of a descriptive statistic include mean, mode, median, standard deviation, range, percentile, correlation coefficient, and proportion. All those one are descriptive statistics. Fine. If descriptive statistic is clear now, can you type yes in the chat so that I know I'm done with that? Descriptive statistic, if it is clear, can you? Because if paraventure in exam, you are like, can you describe a descriptive statistic with example? So when you just give just the definition alone without citing an example, it shows you don't know exactly what you are doing. So you just have to support it with an example. So I take it away from there. I move on to the second types of statistic, which we call inferential statistic. An inferential statistic build on descriptive statistics by going a step further. It's like an inferential statistic is just like when you take a step further. Somebody that got first degree now, and you decided to go and do your master, you take a step forward. So an inferential statistic build on descriptive statistic by going a step further to make interpretation. So that means the definition of the definition of inferential statistic is just like when you go a step ahead of descriptive. That is what inferential statistic is all about. So the focus of inferential statistic on its own is to look at the zoning properties of the population. These one are based, those are those things that are based on probability theory. The valued, the reliable decision, the prediction. You draw conclusion that will be made using those statistical tools. Unlike you could remember when we do what is it called? When we're talking about chi-square, chi-square, you see that we don't just do the calculation alone. We need to make a kind of conclusion. So these are things that you can make a conclusion on. Those ones those things we refer to as inferential statistics. So an example like I said is chi-square, t-test, f-test. Those ones are what we refer to as inferential statistics. I think with this now, you should be able to know the difference between a descriptive statistic and an inferential statistic. So let's move away from there and move on to other thing. So what's the next thing after inferential statistic? Or let me ask the question again. If inferential statistic is clear, can you type yes again? So that we know you really get what I'm talking about. Okay, I've seen yes. Okay, all right. So that's fine. That's fine. So that's fine. So what's the next thing? What's the next definition? It's okay. So what's the next definition? Of course, like I always tell you, don't forget that internet don't forget. If you think you can play upon someone's intelligence, and then if you miss what is it called? Okay, don't let me go there. Don't let me go there. Let me just let you know that some of these things we are saying, they are part of our classes, and it will definitely enrich our knowledge in this statistics class. If they cannot connect, if someone is saying they cannot connect, they should try. If you cannot connect, they should try and go to the channel direct. They should try and go to the channel direct. If at this stage somebody is saying you can't connect or you can't do anything, that means you have something. So with this now, so let's move on to a parameter test. Yes, the next thing is we talk about parameter and non-parameter test. Parameter and non-parameter test. So what is parameter test? These are tests whose efficacy test whether the variable being studied is at least approximately normally distributed. I will take that again. A parameter test. These are tests whose efficacy test whether the variable being studied is at least approximately normally distributed. And examples of parameter tests of significance are examples of parameter tests. Examples of parameter tests are t-test, analysis of variance, then ANCOVA, that is analysis of covariance. You know, I told you the other time, you can just see if somebody asks you what is the full meaning of ANOVA, it means analysis of variance. Then we also have ANCOVA, that is analysis of covariance. Analysis of covariance. So an examples of parameter test is t-test, ANCOVA, regression. Of course, you know, in the course of our own class, we only talk about t-test and ANOVA. We didn't go to analysis of covariance. That is at an advanced level. So whosoever that have the opportunity to go to postgraduate class, you enjoy how to use the statistical tools that we call analysis of covariance. So can you list examples of parameter test? Examples of parameter test. Examples of parameter test. Can we list them in the chat? Examples of parameter test. Yes, as we are listing, we are doing tests as well. Examples of parameter tests. Can we list them? Can we list examples of parameter test? T-test, thank you. T-test, ANOVA, analysis of variance. No. Okay. ANOVA, ANCOVA. Yes, thank you. Okay, can you tell me the full meaning of ANOVA and ANCOVA? What is the full meaning of ANOVA? What is the full meaning of ANCOVA? Yes, someone said analysis of variance. What of ANCOVA? ANCOVA. What of ANCOVA? What of ANCOVA? I didn't, yes. Don't forget that chi-square is not a parameter test. I talk about t-test, ANOVA, ANCOVA, and regression. Okay, that's fine. That's fine. So start listing them. So let me now move to non-parameter test. So for the next 5 minutes now. Okay, wait. So for the next 5 minutes, I want you to give that definition. Use your text. Tell me the meaning of statistic, two types of statistic, descriptive statistic and inferential statistic, parameter test. Then, okay, let me join the non-parameter test now. Non-parameter test. These are tests whose efficacy, a non-parameter test, these are tests that are developed without reference. These are tests, non-parameter tests are tests that are developed without referencing to the distribution of variable. You remember that when we do parameter, we said they are the tests whose efficacy test, whether the variables being studied is at least approximately in the normal distribution. Those are the parameter tests. But for non-parameter tests now, these are those tests that we develop without referencing to distribution of variable. Tests that are developed without making reference to distribution of table. An example of non-parameter tests are chi-square. Examples of non-parameter tests are chi-square, I hope you are taking them down. Wisconsin. Okay, let me just stop that because those are those ones that we did. So I don't want to take you outside those ones. So examples of non-parameter test is chi-square. Examples of non-parameter test is chi-square. So and we said a non-parameter test is just like those are the tests that we develop without referencing to the distribution of variable. Tests that are developed without making reference to distribution of variable. An example is chi-square. Examples of non-parameter test is chi-square. Examples of non-parameter test is what? Is chi-square. So I want to give you test now. I'll test you for the next 10 minutes. Just be there for the next 10 minutes. For the next 10 minutes, can you describe using your chart? Describe using your chart. Look at the board now. Let me face the board for you. So you are going to put your response. You put your response in the chart. Put your response in the chart. Put your response in the chart. So I've told you tests can come at any time. So and that is it now. So it's not necessary, not until when you see physically you start having tests. So you are going to define the following for me in the chart. Define the following for me in the chart. Number one things you are going to define for me is statistic. 1. Statistics. Number 2. 2 types of statistics. 2 types of statistics. So you explain the 2 types of statistics. Number 3. Explain parameter test. Parameter test. Then number 4, non-parameter test. Non-parameter test. So you have 10 minutes in a full chart. If you like, go and copy another person's answer. Thank God you know AI can do all these things. It will just do analysis of those that copies another person's answer. So your time starts now. You have 10 minutes to describe those terms on the chart. Yes, stop now. And if you don't stop, so once I ask the second question, if you can hear me now, can you type yes? If you can hear me now, can you type yes? If you can hear me now, can you type yes? If you can hear me, okay. So I now know that anybody that type anything after the yes. Okay, let me give you for the next 10 minutes. Of course, you cannot help someone to do this kind of a thing. You can only do it on your own. So I will advise you call those that are not here, because we all agree to be in this class together. So those that are not here, you are on your own. You are on your own. So let's take it away from there, and we move on to the next definition. So let's look at some of these terminologies that we normally come across in statistics class, and we'll quickly talk about that. Let's look at some of this terminology, and we'll quickly talk about that. The first thing we are going to look at is what we mean by hypothesis. What is an hypothesis? So list those things down now. Number one, what is hypothesis? What is hypothesis? Number two, what is significant level? What is significant level? Number three, what is one-T test? Number four, what is two-T test? Okay, I'll take that again. Number one, hypothesis. Number two, significant level. Number three, one-T test. Number four, two-T test. Number five, decision rules. Decision rules. Number six, type 1 error. Number seven, type 2 error. So I'll take that again. One, hypothesis. One, hypothesis. Two, significant level. Three, one-T test. Four, two-T test. Five, decision rules. Six, type 1 error. Seven, type 2 error. So I'm going to define them one after the other. Of course, many of you have been hearing us during our normal class. We talk about hypotheses, we talk about the null hypothesis, we talk about alternative hypothesis. What exactly is hypothesis itself? What exactly is hypothesis? What exactly is hypothesis? Of course, for those of you that are joining this, that are in this class, whatever we discuss here will definitely help you in your research method in education. So an hypothesis is a tentative answer. An hypothesis is a tentative answer. Let me face myself so that you can see me very well. An hypothesis is a tentative answer. An hypothesis is a tentative answer to the problem being investigated. An hypothesis is a tentative answer. An hypothesis is a tentative answer to the problem being investigated. If you remember, for those of you that normally come to the class of research method in education, we said before you can carry out a research on anything, the first thing a researcher will do is to first of all identify a problem. Because a researcher don't just go into problem, they don't just venture into researching. They are actually looking for a solution to identify problem. So therefore, as a researcher, the first thing you just need to do is to identify a problem. After you identify the problem, you are going to provide a solution to the problem. And that is where hypothesis comes in. And that's why hypothesis is what? It's a tentative answer to the problem being investigated. A tentative answer to the problem being what? Being investigated. So like I said, hypotheses are often stated in a null form. It is the null hypothesis that will be subjected to statistical test. It is the null hypothesis that will be subjected to statistical test. And of course, some of you know what a null hypothesis means. You know what a null hypothesis means. So if you now test an hypothesis and you are not accepting the null hypothesis, then you have to accept the what? The alternative what? Hypothesis. So that is why we have two types of hypothesis that we call the null hypothesis and the what? And the alternative hypothesis. So in conclusion, hypothesis is a tentative answer to the problem being investigated. It's as simple as that. Just write an hypothesis is a what? Is a tentative answer to a what? To a problem being investigated. So what's the next thing? So what's the next thing? What's the next thing? So what's the next thing? We have defined hypothesis. So what's the next thing? Okay, significant level. Significant. Yes, thank you. Who is that one? Gbadamosi. Thank you, Gbadamosi. Significant level. So what is significant level? What is significant level? What is significant level? The significant level is denoted, is a significant level is denoted as this. Look at this. Alpha. A significant level is denoted as this. Can you see that? Okay, let me show my board. Oh, so sorry. I didn't show you on my board. So, a significant level is denoted as alpha. Significant level is denoted as what? As alpha. Even in exam, even if you don't remember anything, you just said a significant level is denoted as what? As alpha. Is denoted as what? As alpha. A significant level is denoted as alpha. Probability is the probability of rejecting the null hypothesis. Is the probability of rejecting the null hypothesis when it is true. A significant level is denoted as the probability of rejecting the null hypothesis when it is true. An example of significant level is what we normally talk about in the class. We said at 0.05 level of significance, at 0.01 level of significance. That is an example of what? An example of significant level. An example of significant level. That's an example of significant level. So, can you go into the chart now and define the two definitions that I've just talked about now? Okay, let me give you two more. Let me give you two more. Two more. Let's talk about one-T test and two-T test. One-T test and two-T test. One-T test and two-T test. So, a one-T test is a statistical test in which the critical areas of distribution is one-sided. A one-T test is a statistical test in which the critical areas of distribution is being one-sided, so that it is either greater than or lesser than in a certain value, but not true. But not true. That is an example of what? Of a one-T test. A one-T test is a statistical test which the critical areas of distribution is one-sided. Even if you just said a one-T test is a statistical test that is it is one-sided. One-sided, so that it is either greater than or less than in a certain value, but not both. It's just being one-sided. That's why we call it one-T test. It is being one-sided. Now let's move on to two-T test. A two-T test will be test both. A two test will be test both if the mean is significantly greater than x, if the mean is significantly greater than x, and if the mean is significantly less than x, if the mean is greater than x and if the mean is lesser than x. So those are the definition of one T test and what, and two T test. So at this juncture, for the next 5 minutes again, I'm going on with another question. So I'm going on with another question. So I'm waiting for your answer. Waiting for your answer in the chat. I'm waiting for your answer in the chat. So what I want now is number one, what is hypothesis? So you are defining the following in the chart again. You are defining the following in the chart. Don't forget anything after this, I'm not taking that. Number one is hypothesis. Hypothesis. Number two, significant level. Significant level. Number three, one tail test. Number four, two tail test. So you are going to define the four together. Define the four together. Let's go. You are defining the four together. Let's go. So for the next 10 minutes, you are defining the four together. Please, I don't want it separate. Pick your definition like that. Hypothesis, one, hypothesis, just define it. Two, significant level, just define it. Three, one T test, define it. Four, two T test, define it. So for the next 10 minutes. So I'm still here, waiting for you. Don't forget I told you, once your own answer or you are not in this class, of course, there's nothing I can do to that. We all agree to meet virtually and the virtual is what you are doing. So I've just put it there. If you are not in the online class now, you are on your own. You are on your own. I just want you to know that you are on your own. Okay, so I didn't see any comments, so it shows you are all through now. So let's move on to another thing. So this time around now, we have come to the end of written. So we are now going to move on with the calculation. And of course, the calculation too, there will also be a kind of text at an interval. At an interval, we'll be having text. We'll be having text just like the way we have been doing it while we are answering those written as well. So there is nothing that is not possible. I can see some people that are saying you can't comment. If you can't comment, that means your account is not a. You have to check you have to check it very well. So you have to check it very well. Okay, so let's move on now. So let's move on to the next one. So far so good. We have been able to give definition to statistic, descriptive statistic, inferential statistic, parameter test, non-parameter test, hypothesis, significant level, one-tay test, two-tay test. So I want us to look at decision rule. I'm going to add that one to that decision rule. I'm going to add that to that decision rule. Let me add decision to rule to what we have defined. So what is decision rule? What is decision rule? When we talk about decision rule, what is decision rule? Decision rule is a statement. Decision rule is a statement that tells under what circumstances. Decision rule is a statement that tells under what circumstances to reject the null hypothesis. Under what circumstances to reject the null hypothesis. That's just a simple definition of decision rule. A decision rule simply means a statement that tells under what condition to reject the null hypothesis. Don't forget that normally in the class, sometimes I will say when your calculated, that is what you calculate on the table, is lesser than what you check on the table, you accept the null hypothesis. You accept the null hypothesis. But if the calculated, what you calculate, is greater than what you check on the table, then you will not accept the null hypothesis, but rather you will accept the alternative word. The alternative. So that is a simple illustration of what? Of a decision word, of a decision rules. Of a decision rules. That's a simple illustration of a word, of a decision rule. So I hope decision rule is clear now. So you can just cite an examples of this. You can see a decision rule when the calculated is what is lesser than table, you accept the null hypothesis. But if the calculated is greater than the table value, you will not accept the null hypothesis, but rather you accept the alternative hypothesis. You accept the alternative hypothesis. So that's just the simple definition of a decision rule. So a decision rule is a statement that tells under what circumstances to reject the null hypothesis. A decision rule is a statement that tells under what circumstances to reject the null hypothesis. Under what circumstances you reject a null hypothesis. So let's look at two more. So that means after this now, I will come back and conduct another brief test on the decision rule, type 1 error and type 2 error. So I'm still coming there. So let me clean the board for you. Of course, this time around, that's one good thing about online. All of you are in your house now, enjoying, and I'm the one writing and cleaning the board. No problem. God no go shame us. Have you God go shame us? There is no problem. So let's move on now. So I've talked about, so we want to quickly look at that three concepts. Number one is decision rule. Number two is type 1 error. Then number three is type 2 error. What is type 1 error? What is type 2 error? What is type 1 error? What is type 2 error? So let me put this error. Type 1 error, that's Roman figure 1. So that you don't commit such mistake in case if you come across this in anywhere. So what is, I'll tell you about decision rule. That a decision rule is a statement that tells under what circumstances to reject the null hypothesis. So it's just a condition. What condition are you setting on ground to reject the null hypothesis? The only time you can reject the null hypothesis is when what you calculate is more than what you check on the table. What you calculate, when it is more than what you check on the table, then you will not, you accept the what? The null hypothesis. So therefore, a decision rule is what? Is a statement that tells under what circumstances to reject the null hypothesis. So let's move on to type 1 error. What is type 1 error? Type 1 error, just like when I talk about significant level, type 1 error is alpha. Type 1 error is denoted as alpha, while type 2 error is denoted as what? As beta. Even if you don't remember anything, even if you just say type 1 error is denoted as alpha, type 2 error is denoted as what? Beta. You will get at least, even if the mark is 3 mark, you will get 1 mark. 1 mark plus 69, that is 70. You get your 70. It's something. So you don't joke with any of these. So a type 1 error, those of you that are just sending something now, I'm not going to accept it too. That shows you are just joining the class. So a type 1 error is denoted as alpha. This is the error committed. Type 1 error is the error committed when a researcher rejects a true hypothesis. Type 1 error is when a researcher, type 1 error, this is an error a researcher commits when you reject a null hypothesis. So type 1 error is when a researcher rejects a true hypothesis. When you reject a true hypothesis. So that is a type 1 error. So what is type 2 error? Type 2 error means not rejecting the null hypothesis when it is actually false. Type 2 error is what? Is when you are not rejecting the null hypothesis when it is actually the false. Of course, let me cite an example. When your calculated value is greater than the table value, you are supposed to reject the null hypothesis and accept the alternative hypothesis. When you now commit a mistake that instead of you to accept the null hypothesis and you go and take the alternative hypothesis, you have committed the type 2 error. So type 2 error simply means not rejecting the null hypothesis when it is actually the false. That is what we mean by type 2 error. So very quickly in the chart, can we have the 3 meaning of this in the chart? What is decision rule? What is decision rule? What is type 1 error? What is type 2 error? Put it in the chart. Put it in the chart. Can we have it in the chart? What is type 1 error? What is type 2 error? And what is decision rule? Can we have it in the chart? So you have 10 minutes to do that in the chat. 10 minutes to do that in the chat. I didn't say anything in this chat. Oh, what is decision rule? What is type 1 error? What is type 2 error? I'm waiting for you in the chat. So you have 10 minutes to do that. While you are working on that, we'll just do a kind of review on some of those things that we have done. Let's do a review of some of those things we have done. Let's do a review. I'm still waiting. I'm still accepting answer. I'm still accepting answer. I didn't see chat again. Oh. I didn't see chat again. Oh. I didn't see chat again. I didn't see chat again. Oh. Okay, I think I can see it now. So I'm not seeing the chat again. Okay, okay, I can still see. I can see it now. So I'm not seeing the chat again. Okay, okay, I can still see. I can see it now. So I just want to know how my board look like over there. Okay. So I think I can see. So I can see what my chart is giving me now. So far so good. We start the class with measure of central tendency. So we start the class with the measure of central tendency. So on the measure of central tendency, we talk about mean, median, and we talk about what? Mode. That is central tendency. Is that not? So if I ask you that the following are central tendency, except mean, median, mode, range, you should know the odd one among them. So we talk about mean, median, and what? And mode. We move away from there. So let's just do a review on this. Let's do a review on this. Within 5 minutes, let's do a review on this. Let's do a review on this. We said mean is denoted by X bar. And the formula for the ungrouped data is summation Fx over summation F. Isn't it? I think that's the only thing we did in that place. So we talk about median. We move away, we talk about median. For the group data, we say it is L1 plus N over 2 minus cumulative frequency before the median class minus frequency of the median class multiplied by the class size. That is for median. So for mode, we said mode for group data is L1 plus change in 1 over change in 1 plus change in 2, everything multiplied by class size. That's the formula. I hope you can see. Yes, you can see my board. So that's the formula for all the 3 central tendency. And I define this for you. If you're having issue with that, you can go ahead and watch the video. The video is still live on the page. So you can go ahead there and watch. So that's that. So that's not where I'm going. So for those of you that are putting something down, that are jotting something down, I want you to jot this one down. Just make sure you confirm all those things that I'm putting. And if there is anything that is not clear there, let me know. Let me know. Let me know. Let me know if there's anything that is not clear there. Let me know if there's anything that is not clear there at all. So we take it away from central tendency, then we'll move on to we take it away from there, then we move on to another thing. So we move away from there, we'll move on to this. So we move away from there, we'll move on to where we talk about inferential statistics. We talk about those inferential statistics, where we talk about Spearman ranking. So I'm going to give you this. So let me just give you this to warm up. I'm sure there's no way you are there without your jotting material. Don't forget, I always tell you that what? A fainted pen is better than best brain. 10, 12, 8, 5, 6, 15. So let's move on to the second one. 2, 28, 3, 18, 20, 10. So you are going to use Spearman ranking. Spearman ranking. And I hope we still remember the formula. So can we rank? What is the rank of X? What is the rank of X? The rank of S. What is the rank of Y? What is rank of S? What is rank of Y? Can you rank Y? Rank X and rank Y and put your answer in the comment section. Quickly. I hope you still remember ranking. So I'm waiting. Let's rank. Let me just take this. For those people that are saying they didn't get it very well, let me assume I have 15, 10, 20, 30, 17. And I'm to rank this one now. If I'm to rank this one now, what's the highest number here in terms of position? Who got first position? 17 will get first position. No. 20 will get first position, followed by 17. Sorry, let me take that again. So who got the first position? The first position is 20, followed by 17. The third position is what? Is 15, followed by 10, followed by 3. So what I've just done here is that if this is P, this is just rank of what? P. So that's exactly what Spearman rank is all about. So can you rank this now? So if you have to put this one in the chart now, so the ranking is just 3, 4, 1, 3, 2. So that's what I expect you to put in the chart. So just tell me like this one now, my rank P, because it cannot take subscripts. Just say rank P is this. So for you just say rank X, list them, rank Y in the order that we have it on the board. So can I have it? Let me see those that will get that. Thank you, Sultan Ayodele. Thank you, Sultan. That's exactly what I want. If you like, go and copy another person's own. If that person miss it, you all miss it together. You all miss it together. So it's better you watch it very well. So you have 10 minutes to do that. You have 10 minutes to do that. I'm not seeing comment. Oh. Yes, thank you. Thank you. In fact, many of you just clap for, use emoji to clap for yourself. Use emoji to clap for yourself. I like that. So that's a great one. That's a great one. So let's rank together now. So on the ranking of X, which one is coming first? The first position is 15, followed by 12, followed by 10, followed by 8, followed by 6, and followed by 5. So the ranking of this one now will be, so that means the ranking of S is 3, 2, 4, 6, 5, 1. So who got it? Who got it? Let's see who got it. 3, rank of S. Hey, these people did not get it. What happened? Is anything wrong? The numbers that we have there is 6 numbers. Why am I having 5? Who got it? Okay, Daniel got it. All right. Daniel got it. Blessing also get it. That's good of you. That's good of you. Some people go ahead and start copying what I put on the board. You are on your own. Okay, so let me go to rank of Y. The rank of Y, what's the highest? The highest here is 28. 1, followed by 20, 2, followed by 18, 3, followed by 10, 4, followed by 3, 5, followed by 2, 6. So the ranking of that place is 6, 1, 5, 3, 2, 4. Who got it? Who got it? Who get that? I didn't see anyone. Yes, you got it. Ayola. That's great. So this is not a shy play. So the difference between the D now, the D is just talking about the difference between the rank of S minus rank of what? Of Y. The difference between the rank of S and what? Rank of Y. So what's the difference between this one? 3. Difference between this one? 1. Difference between this one? that's minus 1. Different, 3, different, 3, different, minus 3. We got it? If you don't get it, so what do you get as your own difference? What do you get as your own difference? So what do you get as your own difference? So what do you get as your own difference? Let's see what you get as your own difference. So what do you get as your own difference? What do you get as your own difference? So I'm waiting for you. What do you get as your own difference? Do we get the same thing? So after getting that now, so can we square the d square now? So that will be 9. That is 3 square, 1 square 1, 1 square 1, 3 square 9, 3 square 9, 3 square 9. So can we add everything together? And let's apply the formula now. So I'm waiting for you. So let's apply the formula now. So let's apply the formula. So that is 1 minus 6 into summation d square over n into n square minus 1. So can we put it into the, can we get, what is summation d square? What is our summation d square? Somebody is saying summation d square is 38. Is that correct? 9 multiplied by 4. Yes, you are right. Somebody is saying 28. Why would summation d square be 28? 9 plus 1, this is 10. This one, 20. 20 plus 18, that is 38. So summation d square is just 38. So when you pack everything into the formula, that will be 1 minus 6 into 38 over n. Our n now, 1, 2, 3, 4, 5, 6. So our n is just 6 into 6 square minus 1. So let's take this. So that is 1 minus. So let's open the bracket. 6 multiplied by 38. What is that going to give us? 6 multiplied by 38. So can somebody help us to do that? People at home that have not started eating rice, that have not started eating Christmas rice. So 6 multiplied by 38. Yes, good of you. Who is that? Thank you. Almost all of you got that right. So that is 228 over, then let's take this. So 6 square is 36. 36, take 1 away from 30, that is 35. That is 6 multiplied by 35. And that will give us 210. So what you just have to do here now is just say 228 to be divided by 210. So what is that giving us? So as for me, it's giving me 1.085. So I will take that away from 1. So that will be 1 minus 1.085. And that will give me minus 0.085. So that's my answer. So this question is just a practical question. That's why I just put what I like there. So that's just it. So, who is getting 1.085? Yes, take that away from 1 now. Take that away from 1, the constant 1. Take that away from constant 1. Take that away from that. Yes, correct. You are right. So that is that's about Spearman ranking. So can we move on to? Okay, let me just give you a very simple one. So just a revision on that. So let's go back to another thing. So I'm going to give you this. Do this. Use Spearman ranking. I'll give you 15 minutes. Just the final answer. Just tell me the final answer. So if you have x over y, I hope you can see the board very well. If you can't see it very well, just let me know. So you are going to use the Spearman ranking. X is 5, 6, 7, 3, 4, 2. Y is 8, 9, 10, 6, 4, and 3. So I hope you can see it very well. Yes, you should be able to hear me now. So can you use Spearman ranking? You are using Spearman ranking now for this. Spearman ranking for 10 minutes. 5, 6, 7, 3, 4, 2, 3, 6, 10, 9, and 8. So you have 10 minutes. Just drop your final answer in the chat. So when you want to drop the answer in the chat, tell me your D square. What is your D square? Then what's your final answer? Okay, that's great. I can see. Okay. Okay, that's good. That's good. That's good. Please, if you can hear me, can you confirm? Don't tell me the network is bad, though. That's what I told you. Don't tell me the network. If the network is bad, I don't know if you can look at it very well. For some of you that have been to my office, this is, can you see in my office? So I'm still in the office. So if you tell me the network is bad, so don't tell me the network is bad. I don't want to hear that. Okay, so that's great one. Somebody said the answer is 1.9 C's. Okay. Another person is saying the answer is 0.0943. Okay, all the same. All the same, we work it together and we see what the answer is. So that is that on Spearman ranking. So I want us to use the same thing for Pearson now. Pearson correlation coefficient. I pity those that are not here because it will look as if you are taking us for granted. And you are not taking me for granted, you are only deceiving yourself. So that's one thing I want you to know. So you are only deceiving yourself, not me. So you are only deceiving yourself, not me. Yes, I know some of you are going. So now that is okay. So let's move on to the last thing we are going to do for today. I think we have tried. I'm going to release us in the next 10 minutes. I will release you in the next 10 minutes. But before I release you in the next 10 minutes, I'm going to give those that are still here a bonus. Bonus for being an obedient student who is ready to learn. So it's okay. If you can hear me clearly, can you type yes? If you can hear me clearly, can you type yes? So I'm picking the yes of now. If you can hear me clearly, can you type yes? Clearly, type yes. Okay, so that's good. That's good. So I know those that can hear me clearly. So because I can see some people are saying network. They'll be giving different excuses. That's what they'll be giving us. You start hearing excuses like network. Some will even go ahead and give excuses that I don't have data. So let's use the same formula for Spearman ranking. for Pearson. Use the same formula for Pearson. So what I just want you to calculate is, can you calculate your x square and your y square? So calculate your x and y. So x square and y square. Put your answer in the comment. So like I told you, for those of you that are waiting, so I have Prof here with me. Well, good afternoon to you. GCP 318 class. I want to assume that you have gone a long way. The only thing I want to call your attention to is that statistics is part of psychology, and if you must go a long way in counseling psychology, you need a good knowledge of statistics. Number one is because we deal with human beings, so most of our researches are behavioral in nature, and for you to be able to thoroughly dissect such information, you need statistical knowledge, starting from understanding the concept of statistics itself, the branches, when you talk about the descriptive statistics, the inferential statistics. And you know, each of them also have what we call sub-branches. When you talk about the descriptive statistics, we are talking about those tools that can be used for objective descriptions. That is, without being biased, you want to give information the way they are without manipulating them. So you will need those set of descriptive tools, including the measures to condense data. That is, those tools that will help you to be able to put large volume of data in a very short form. So in that category, you talk about frequency distribution table, you talk about percentages, you talk about ratios, and the rest of them. Then you also have the measures of central tendency. That is, those tools that we use to determine how your own score, how close is an individual score to the central score. So we call them the measures of central tendency. In that category, you talk about the mean, the median, and the mode. So then you must also be familiar with the measures of dispersion, those tools that we use to determine how far are you from the central score. So in that category, you talk about the range, the variance, and of course the standard deviation. And of course, when you move from there, you talk about the measures of relative standing. That is where we talk about percentile, about decile, about interquartile range, and the rest of them. So please look at all those descriptive issues. And when it comes to inferential, we also talk about the two categories of inferential, the parametric tools and of course the non-parametric tools. When we say parametric, those are powerful statistical tools that will allow you to be able to make conclusions without being biased, and in a way that allows for minimal
marginal error. You will have removed most of the marginal errors. So try and look at the parametric tools and of course the non-parametric tools. And of course, the goal of this course is that you must be familiar with at least and master at least one of those parametric tools. Maybe the student t-test, or you are talking about the PPMC, or you are talking about analysis of variance, or you are talking about multiple regression. Try and see that you are familiar with these tools that we are talking about. And for non-parametric tools, there are some studies that you will carry out and which will not make themselves amenable to the parametric conditions. So in that sense, we make use of the non-parametric tools like the chi-square, like Spearman RHO, like Man-Whitney test, and the rest of them. So I'm sure you are in good hands, and those who have been handling it will have taken you through some of these tools. So try and revise them very well. Don't just study for exams. Although the exam is important, we expect you to do very well during the exams. And where you have challenges, let us know before the exams so that those topics can be revised and you'll be able to say that, yes, I mastered this. Then, of course, when you go for the exam, remove all the anxieties, the what we call phobia, the mass phobia and all of them. Remove them, because this course is not exposing you to pure mathematics. We are just looking at just a small branch of mathematics, that's statistics. And the good part of statistics is that you do very little. We only do addition, subtraction, multiplication, and division. You see that we are not asking you to prove anything. We are not subjecting you to equations. So you are not doing any factorialization and the rest of them. So what you are simply doing are those four things, which our children also do. Your younger ones in primary school, secondary school, they do addition, subtraction, multiplication, and divisions. So I wish you all best of luck, and of course success not only in this course but in the whole program. Thank you very much.
Thank you very much, sir. Yes, sir. So what do we say? Can we say thank you, sir? Okay. They are saying thank you, sir. Thank you very much. Thank you very much. All right. Yes, sir. Thank you, bro, sir. All right. You are very good, sir. Yes, sir. So you can see, I think with that, for you to know, presently as I'm talking to you, we are still in the office. Just make sure that we get it right on this. Okay, thank you very much. Thank you very much. So I think on this note, because of our time, so what I would do now is I've tried to collate all those videos. Okay, so for the next 5 minutes, complete this and put your answer in the chat. Then I will come back. Then we'll round it up. Let me just quickly see the prof off. Let me see the prof off and thank him for coming into our class. So complete what you have on the board. Then we call it a day. So once you complete this, then we'll call it a day. Don't go. Wait for the last message. So far so good. So that is how far we can go on this class. And I think with this, you should have if not 70% confidence, let me say 60% confidence to go into the exam and then write your exam. As you have heard from Prof, you don't need to constitute any fear at all. And I wish all of you success. So by the time you return January 6, by God's grace, we'll come back. We'll have our first physical class on the 9th. On the 9th of January. So we are going to have our first physical class on the 9th of January. I've checked some of those your tests. Some of you try what you can do, but I will just try to see if you can still do one mop-up test. So on this note, I want to wish all of you Merry Christmas, enjoy your break, and make sure you are safe wherever you are. So see you on January 9. See you January 9, 3 p.m. See you January 9, 3 p.m. I will repeat myself. See you January 9, 3 p.m. So I'll just give you like 5 minutes. You can greet yourself. Just greet yourself with chat. And then those people that want to go, you can go. I will leave it here. You can greet yourself. I wish you Happy New Year in advance and Merry Christmas to all of you. So you can greet yourself. Just greet those that are on the chat for the next 5 minutes. So, but as for me, I'm done with the class.